This is a video about how to find the area of an irregular polygon or shapes that don't have one specific formula. So if we look at this polygon over here, you can see that it doesn't have one set formula. It looks kind of like a rectangle with a triangle and a piece missing. We want to know what's the area of the shape in blue. So to do this formula, we kind of have to have a game plan. So, game plan. I suggest you make one of these every time you are attempting one of these problems. So split the shape into pieces that you can use known formulas for to calculate the area, and then add or subtract those areas to get the overall area of the shape. So when I look at this shape, I see triangle, rectangle, and then a smaller rectangle. So what I'm going to do is I'm going to find the area of this rectangle and add it to the area of this triangle, and then subtract the area of this rectangle out. So to do that, actually, I'm going to essentially put a line right here and split it across. You could do it other ways. You could take the line and split it right here, and you'd have a rectangle here, But this shape then becomes a trapezoid. You'd have to know the formula for area of a trapezoid, or you could make a separate rectangle here. So you'd have rectangle, 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 triangle. But I don't think that's necessary. I think the easiest way to do it would be to do it the way I'm going to do it. Another option, though, would be if you wanted to imagine that this is one huge big rectangle. Find the area of the big rectangle, then take away the area of this triangle that sits out here, and take away that one. I'm going to show you the example for the one I've already set up. So I'm going to find the area of this rectangle using the formula, length times width. Get a length of 10 and a width of 8. It doesn't really matter which one you pick as length and width, as long as you use one and the other, and you end up with an area of 80, and it'll be feet squared. We'll make sure we put those units in at the end. The area of a triangle, the formula is pretty similar to a rectangle. It's just half the one for the rectangle, because your triangle is a half of a rectangle. So it's the base times height. The base is 8, the height of this one, because the whole piece was 16 and this one was 10, what was left over is 6. So this height is 6. So we do 8 times 6 is 48, and half of that is 2. So the area of that one is 24. And now we have this little rectangle over here, and we use the formula for area of rectangle for that one, and we end up with 16. So to put it all together, to find the area, we're going to add the rectangle and the triangle together. 80 plus 24 is going to give us 104, and then we're going to subtract 16 out of there, and we end up with 88 square feet. Our units are square feet or feet squared, because we're finding area, which is one side times another. Okay, let's look at another scenario. So it says find the area of the hipped roof, and so we want to find the area of this right here. So we've got 4 triangles that make up this roof. For triangles, we have the formula that says area equals 1/2 base times height, or base times height divided by 2. So we need to know the base. The base looks like it's 40. The height is 15 feet 6 inches, or 15.5 feet, 15 and a half feet. So here's our formula for the area of a triangle, and plug our numbers in. 40 times 15 and a half divided by 2. We get 620 divided by 2, and we're going to get the area of a triangle. One triangle is 310. So that's one triangle, but remember we have 4 triangles. So 310 times 4 is going to give us 1240. The area then is 1,240 square feet. So we're piecing it together just like the last time. Well, what if they said, okay, find the area, and then this is a roof and we're going to put shingles on it. And one bundle of shingles covers 33 square feet. And they want you to allow 20% extra for potential wastage. How many bundles of shingles would you need to cover the whole roof? And they want us to round to the nearest whole number. Okay, so we're looking at this one. We've got 1,240 square feet. And then put it over 1 because I make a fraction. And we need to kind of convert the square feet into bundles. So I want to put square feet on the bottom because I'm going to get rid of it. Square feet goes on the bottom, bundle goes on the top. So there are 33 square feet in one bundle. The square feet and the square feet cancel out and they're gone. So you see what we have left over is bundles, which is what we wanted. This means 1,240 divided by 33 square feet. They said they wanted to allow an extra 20%. 100% would be the number 1. 20% is 0.2. So we're going to multiply this answer times 1.2 on the calculator. And we end up with 45.09. And we need to round that to the nearest whole number. It's going to give us 45 bundles. To finish this all up, just want to remind you about some good strategies for solving geometry problems. So write the problem down and draw the figure out. And when you're drawing the figure out, label the pieces they give you. Pick and write down the formula that you need, or the formulas that you need, and use your formula sheet. That's what it's there for. And then label and plug in the numbers that you know and solve for what you don't know using order operations, or if you're solving for, they give you the area and you're solving for the side, do inverse operations. And then once you get your answer, check to make sure you're using the appropriate units. If they're asking for volume, it should be something cubed or cubic. If they're asking for area, surface area, it should be something squared. When possible, go back and check your work. So if they're asking you, if they give you the volume and they're asking you to find the side length, and you get the side length, go back and plug it back in and see if you get the volume you're supposed to get. Well, I hope this helps you out and you're really successful at these problems.